Good afternoon, everyone. I hope you guys enjoyed your lunch. My name is Aya Yadi, and I will be your host for today. Our guest speaker today is Brad Beitler. He is an experienced international executive with demonstrated track records of success in growing business through the application of new technologies and creative business models. He served as a corporate officer for a Fortune 500 company during the past 10 years, which included participation in planning and executing a large. Brad was elected for several JV boards over this period and was responsible for several acquisitions. Recently retired from Technip FMC as an executive VP and CTO, Brad now works with companies that can benefit from his experience in corporate governance of recurring businesses. Please give a warm welcome to Brad.
Thanks, Aya. It was a very nice introduction. Thank you. Like you said, my name is Brad. I hope you all had a nice virtual lunch. I know I had a good one. Today, I'm going to give you hopefully a different perspective on data and data science and how it couples with the broad spectrum of technologies and with things like sensors and imaging and process technologies and things like that. Because I think when you start thinking about the connections between all that, you can really see how innovation can be driven at lots of different levels. Most of my career has been spent in the realm of engineering and technology, primarily in energy. I noticed one of the presentations earlier was about digital transformation. My boss asked me at one point what I thought of digital transformation, and I said, well, actually, ever since I threw away my slide rule, I've been going through digital transformation myself. So to me, digital transformation is more of an evolution, and I think we're going up the curve exponentially over the past few years. So shouldn't be a shock ever since we threw away our analog stuff, although I still got an analog watch. I think we've been on this pathway, this journey to transformation. You can stare at this a minute. Part of what I want to talk about today is innovation, and innovation is important, I think, to all of us. I know all of you have been through innovation, and especially in the evolution and transformation of data and how you move data around. But there's lots of different kinds of innovation, and you can probably identify with a couple of these, and certainly I can identify with that lower bottom right one. Been there a few times, as we mostly probably all have. But innovation is different things to different people. But if I wasn't, I wouldn't be a good consultant if I didn't use a 4-box matrix to describe innovation. So what you see here is a little consultant's 4-box matrix with 2 axes. One's called impact, and impact means, what's it doing to what you want to accomplish. If the impact is if you want to make more profits, or if you want different generations of technologies or whatever, that's the impact. That's kind of your own definition. And then risk is fairly simple. There's a lot of financial risk involved in innovation. And so how much does it cost? Is it going to work? Is it, what are the risks in doing these things? How long is it going to take to be able to do that? So let's, going the wrong way. So let's talk about the different types of innovations that kind of fit into these boxes. The first one I call incremental. Incremental innovation is, if an engineer wants to change a left-hand thread to a right-hand thread, or wants to make a tweak, this is more tweaking things, but for a productive result. You tweak a design so that it performs better. Engineers are always taught to improve things when they're in school, and when they get out into industry and areas, they want to improve things. And so there's a lot of incremental innovation that goes on, and you see it a lot. And I think you saw it in that last cartoon. A lot of that was real incremental. The other one is sustaining. This is the area where you want to pull ahead of the competition. You want to innovate and have something that gives you competitive advantage, true competitive advantage. And these generally aren't incremental. These generally pretty substantial innovations that move you ahead of the pack, or get you up the curve, or have you make considerably more money, or they truly accomplish and have impact on the things you want to do. And this is the one we all like to talk about as disruptive. This is the disruptive innovations are, you can name a bunch of them. Think about electric vehicles disrupting the gas market. Think about 3D printing. That's hugely disruptive. Machine tools. You used to take a lathe and a welding machine and build things. Now you can 3D print things. That's highly disruptive. So, but those things came at a pretty high cost and pretty high risk to be able to implement those things. But disruptive is kind of what you look for. That's what you hope for. Then there's this thing called radical, and you can you can describe this as maybe the domain of Elon Musk. That's where he lives. He kind of lives in the radical innovation area. Very high risk. Not sure exactly if the results are really going to get you where you want to go, and also very high cost. It takes a long time generally to get a radical innovation implemented and actually performing and doing what you want it to do. So as an executive, as a CTO of a fairly large company, that I had a pretty significant R&D budget, but you had to make some choices as to what did you want to focus on, where did you want to throw the money. And so as you kind of look at what choices you want to make, I looked at incremental innovations. That some unintended consequences with incremental innovation. And you can kind of apply this to a lot of different things. You can apply it to software, you can apply it to hardware. A lot of what we try to do in developing products is to standardize. If you can standardize, you can replicate things, you can make them cheaper, you can open up a broader market. The problem with incremental innovation is it disrupts standardization. So you wind up having to go and do version 2 or version 3 or the release number 2.2. And the more you do those incremental innovations, the more it kind of disrupts your flow of standardization, and it may restrict the amount of money you can make. So while they're good in a lot of ways, those aren't the areas I wanted to invest in when I was doing my job. The other thing too was radical innovations. I just figured let's leave that to Elon. It's pretty risky. It's way out there. It takes a lot of money to do it, and we've got better things to focus on. So the things from an executive perspective that I like to focus on were the sustaining and the disruptive. But I think the one thing to keep in mind is, as you go from sustaining to disruptive, you might evolve from a sustaining innovation to a disruptive innovation as you go through the process of thinking about how the sustaining innovation is actually implemented. When you think about all the different things you can do that may actually go over and disrupt the market, disrupt the technology. So I think there's a case to be made that as you're developing the evolution of the innovation, you can actually develop a revolution too. So that's what I'm going to focus on, of these kind of sustaining and moving into disruptive type innovations. So then, somebody asked me, well, how do you innovate? Well, that's a multi-answered question. You can see the list here. You get a good idea. You get a team that wants to develop a better process. They say, for guys like me, CTOs, you need to create an environment of innovation, which is an interesting concept. There is a lot to that, and if you create that environment, then you get some good ideas, and you get a lot of interesting interaction, especially among different entities. For example, whenever I got the manufacturing guys together with the engineering guys, with the field operators, we got some great ideas because they came at it from different perspectives. It's important to get that diversity and that differentiation together to be able to work on things that they can focus on. Brainstorming is always a fun thing to do. The thing I found was good for my thoughts and innovation was to go out and listen to customers, talk to them. They've got some pretty good ideas, and they're the ones using this stuff. So I think all these things play into it. But the thing I found the most interesting was this discovery of a new tool. And when I say tool, there's all kinds of tools that you get, and I think I may even have a list of them here. Let's see. Tools. Think about the list here. When the plow came along, that was a tool, but boy, it enabled all kinds of things. You take that plow, you revolutionized the farm. The transistor, when I think it was Bell Labs invented the transistor. So many productive devices came out of that. Same with the chip, same with CAD systems. All of a sudden, I was there when all of a sudden the first CAD system came out, and we threw away our drafting boards and our T-squares and began using our 286s and 386s, so some of you may remember, to be able to do CAD programming. And that quickly enabled things like 3D printing, direct manufacturing on machine tools. So these tools that came out of a lot of different areas, when we took engineers or people that were actually applying the tools, that's where the real innovations came. Now, in and of themselves, CAD and 3D printing, silicon chips, those are innovations. But the real innovations came when you put the two of those together. And that's what I saw. And then data analytics came along. And I think the first time we saw that was with the airlines, with jet engines, about how if something went wrong in a jet engine while it was flying, the people in the cockpit could see it, pilot could see it, on the ground crew could see it. And so there was a guy with a toolkit waiting when the plane landed to go fix whatever the problem was. And then they moved into the predictive mode, and we see that being used a lot with digital twins and things like that. So the tool enabled the effective application that really then solved the problems and accomplish the goals of whatever they set out for. So you have to combine the domain, which is the airlines or the oil field or whatever, along with the tool to really get the maximum benefit from the innovation. So we came here to talk about data analytics and data and how that drives innovation. And there's just a few industries, and ones that at least two of them I'm familiar with. The middle one I'm familiar only because I go to the doctor every now and then. But certainly in these industries, especially the process industry, data analytics has really played a key role, or is starting to play a key role in predictive maintenance and producing uptime results. One of the things that I think to keep in mind is as you think through data and how you use it, is that when you're talking to companies who are going to use the data, the guys running the companies are really after making more money. Their sole job is to make sure that company is making money now and even more tomorrow. And so whatever you put in place with data analytics, things of that nature, has to produce monetary results somewhere down the line. The sooner the better. And so as you talk to executives, that's the message you're going to get. And I think in a lot of cases, if you look at some of these, for example, process industries, if you can predict maintenance coming up or predict problems, it reduces downtime, which means the throughput of whatever you're refining or the oil field or whatever, the throughput's higher, and that means more money in the pocket of the customer. So keep in mind that whatever you do on the data side has to somehow produce profitable results for the companies that are actually applying it. So this is where we talk about data analytics tightly linked with domain knowledge. On the right, you see lots of domains. You see Elon Musk's rocket, that's SpaceX. You see oil drilling rigs, you see refineries, and you see car assembly lines. And each one of those discrete areas has a set of data that it generates through sensors, through images, through a lot of different means. And certainly in my early days, we figured out what sensors were and how we could actually measure the data. But then the data would just pile up on somebody's desks and nothing would happen. So somehow it's got to be tightly linked with the two have to be pretty tightly linked. So raw data is a great. Sensor technology's gone through the roof. There's all kinds of ways we can collect all kinds of data, and it goes into this bucket. I think you call it a data lake. Then there's a couple things that have to happen there. And I think a couple of the presentations before me talked about structuring data and how the data gets fished out of the lake and made so it's usable. But the key there is to get the data to people who actually understand it. And I can tell you now that domain engineers don't necessarily understand all the data and the way it's collected. And the data analysts probably don't all understand the domain and what goes on inside there to be able to make sense of it. So somehow you have to couple the two together, and on a platform that where the engineers can understand the data analysts can understand the engineers, and they go forward jointly in trying to figure out how to make the processes more productive and how to make more money for the company. But putting those together on a common platform where you can couple the two together will provide you with significant process improvements, innovation, game changers, and I think one of the things that sometimes we ignore is new business opportunities. As we gather data and understand more these processes, what comes out of it is there's opportunities for service businesses, and I'll go into those in a couple of minutes. So we can talk about products and innovation and how a lot of the data will help innovation of the products. But we got to talk about too about how these startup service companies can come out of this whole thing and also be very innovative in how they deal with some of the basic things like the domains on the right. So let's talk about one that is familiar to me. We used to do a lot of work in the LNG side, and actually I sit on the board of a company called Flutura, and they're a really neat little AI machine learning company that actually does a lot of this integration of domain knowledge and data, and they provide platforms that the engineers can actually understand, and the engineers can work with some of the data science to be able to come up with the right kind of solutions for their area. But anyway, these big LNG carriers, and you may have seen some of these, they really didn't have a good means of analyzing or anticipating onboard incidents. You can imagine there's those balls there on the top of the LNG carrier are full of methane, frozen methane, and if that stuff gets unfrozen, it turns into a pretty volatile gas. And so any kind of incident is pretty critical and pretty important to fix and report and even predict if you can. So there's a lot of stuff to read, but bottom line was they brought in this little company Flutura, and they were able to come up with sensors, come up with predictable algorithms. Artificial intelligence kind of filtered out all the spurious stuff, non-critical issues, and they were able to provide observations and also, sound warnings if something was about to happen or happening, and then could share the data by satellite with the shore base to be able to understand the problem and how to fix it. And then when the LNG tanker gets to port, they're there waiting with the toolkit, kind of like the guys on the airplane. So integrating all these things enable the crew to analyze and predict and model these things. Now, this is an example of a great business opportunity for a service company. Very innovative, using tools, using proven tools, and innovating in terms of their ability to produce results that actually help the bottom line of these LNG companies. Now, I'll talk about another one. This is kind of going out a little in the future, although it's starting to happen now, is carbon management. There are a lot of things, as you are well being informed through the press these days, a lot of stuff emits CO2. But there's a burgeoning market for CO2 for a lot of different uses. There's technologies being developed right now to be able to sequester, manage emission reductions, capture CO2, store CO2, transport it. We can use it in different applications. So it's very complex, and you kind of overlay that with all the different governmental regulations, with the carbon tax, all the different carbon trades. So it's very complicated and a very difficult task, and especially if you're a company that wants to optimize your performance and maximize the amount of money you can make out of whatever piece of this value chain you're taking on. So I think, and this is a bit a crystal ball into the future, not too far in the future though. The scope 1 and 2 emissions, everybody's monitoring those, and that's basically the emissions that you as a company are making. Get into the scope 3 emissions, which are all your subsidiary suppliers and things like that. That gets very difficult and very, very complicated. It's kind of the holy grail of how we measure these things. But to model the system, to place the sensors, to determine all the parameters, to figure out how you actually analyze the data and then optimize it is going to take a monumental effort between the data scientists and the actual engineers and the people and the corporate that are trying to make money in doing all this, and also trying to genuinely reduce carbon footprint. So I think one of these days we're actually going to talk about instead of carbon offsets, we're going to talk about actually true reduction of carbon. So I think there's a lot to be done in that area. But I think again it's a business opportunity. This is coming up, and could carbon capture or some sort of of carbon analytic business be a great opportunity? Well, sure it could. But I think that the innovation is going to be, how do you translate this tool that we have called data analytics? How do you translate that along with the domain experts into something where you can actually make money and have a good business opportunity? So couple of examples. Evolution to revolution. So you start small, but you aim big. And but I think the key takeaways here are, you really got to integrate the data analytics tools with the domain experts in all the different domains that you enter. Data in and of itself is great, and I think companies that do that are going to do very well. But the key to success is going to be integrating the two and really understanding the domain and how the data relates to it and how that can be used to maximize the outcomes that these companies that are in the domain businesses will produce. So that's the end of my sermon for today. It's a really interesting space. It's one that has a tremendous future, and you're going to see a lot of startups and see a lot of people making big strides, and you're going to see a lot of industries realizing that all of a sudden they have opportunities here where they didn't have opportunities before, to be able to maximize their profitability and utilize data to their own benefits. Anyway, that concludes my 25 minutes worth of advice. So
thank you so
back
much.
to you,
I really appreciate it. So a few questions we have. What's the best way of joining the effort of the data scientists and the engineers in order to obtain breakthrough results?
Probably first thing is to introduce them to each other. That would be a start. Funny enough, in my experience in big companies, there are departments in big companies that should be sitting right next door to each other, but they literally haven't met each other yet. So first get them in the same room. Then I think you have to also think about platforms. What kind of platforms can you use to have them working on the same platform? And when I say platform, a workbench, you might say, a digital workbench, to be able to have the data guys working along with the domain guys, and to come up with common conclusions and common things. So I think those are probably the two main things. But
okay, we have, how can data be managed better to drive this breakthrough?
How can it be managed better? That's kind of a broad question, but thank you for asking it. I think first of all, the data, from what I've seen, the previous presentations, I mean, there are lots of good ways of structuring the data, but I think it's how do you get the meaningful data to be able to go into the analytics, and to use the meaningful data to be able to predict and to be able to derive conclusions. And I'm not sure you get the meaningful data until after you've gone through a few cycles of prediction, and then you can kind of narrow down on what's significant and what isn't. But I think sometimes we get drowned in way too much data, and I know that's I think I mentioned that in the old days it used to just pile up on people's desks at these printouts, and that didn't do anybody any good. So I think focusing in on the data that really means something and is determinant to the outcomes is probably the most important thing. And that I'm sure that has something to do with the structuring of the data, and something to do with the types of instrumentation we use and things like that. But I think that's a conversation between the data people and the domain people to figure out what are the most critical things we should be paying attention to.
Very interesting. The last question I have here is, what can executive management do to stimulate innovation in this space?
Yeah, interesting. That's so I mentioned creating an atmosphere, creating an environment of innovation. It's not easy. I think, but it's important. I think an environment of innovation has to involve a lot of different disciplines in an environment that allows new ideas and allows brainstorming and and allows some prototyping and some things to go on that actually can do proof of concept and things of that nature. So I don't know what we did. We set up a prototype lab and opened it up to all the engineers and said, okay, you got so many hours a month you can spend, pursuing some new ideas, and you can build a prototype out of wood or metal or whatever you want. And that seemed to work out pretty good. Some, not everything was a usable idea, but a few really good ideas came out of it. Now, that was a physical lab where you had machine tools, but you can set up the same kind of labs with digital or whatever. But I think it's letting the creative people have some time to be creative and encouraging that. And I think that's a real key. Too many times we chain the engineers to their what used to be the drafting boards, now to their computers, and tell them to work and be productive. But creating that environment's a really important thing. A lot will come out of that.
Very interesting to hear. Well, thank you so much for giving this presentation. I learned so much and it was very interesting. Thank you to the audience for joining us this afternoon, and I hope everyone has a wonderful rest of their day.
Thanks.